Hi, I'm Mukesh Gautam. Today I'm going to present our paper entitled Cooperative Game Theory Based Approach to Under Frequency Load Shedding Control. My co-authors are Narayan Vishal and my advisor, Dr. Mohammed Benitris. Let's start with the background. Under frequency load shedding is a crucial factor for frequency stability and control. Conventional offline under frequency load shedding methods said fixed amounts of predetermined loads on a predetermined schedule. Contrary to that, this paper presents a cooperative game theory based two-stage strategy to effectively and precisely determine locations and amount of load to be saved for under frequency load shedding control. The proposed approach is implemented on the reduced 9-bus 3-machine wake system and is simulated on RTDS. I'll explain about the proposed under frequency load shedding approach. The proposed cooperative game theoretic under frequency load shedding approach is implemented in the following two steps. In the first step, disturbance power is calculated based on rate of change of frequency, RCOF. And in the second step, locations and amounts of load shedding are determined using Shapley values. Shapley value is one of the solution concepts of game theory, cooperative game theory. The swing equation is used for calculation of disturbance power. This is the swing equation. Using this, the disturbance power of each machine is computed. Where here delta is small delta pi with small p is disturbance power of each machine. And when we add the disturbance power of all the machines, we get the total disturbance power, PD, total disturbance power given by PD. And then this can also be expressed in terms of FC, where here FC is frequency of the overall system referred to center of inertia. Load shedding amounts distribution factor is computed, and then using this formula. In this formula, dk is the distribution factor, and distribution factor for each load shedding location, and psi k equivalent is the equivalent Shapley value of that particular location. And then finally, the load shedding amount is calculated using this formula by multiplying distribution factor with total disturbance power. We get load shedding amount for each location k. The solution procedure starts by reading system data and computing disturbance power PD using initial RCOF after disturbance. And then candidate locations participating in load shedding are selected. And for each coalition, characteristic functions are computed. And then Shapley values and then equivalent Shapley values for all coalitions are computed. Finally, load shedding amount for each candidate load shedding location is computed based on distribution factors. The proposed approach is implemented on the reduced wake 9-bus system. And for in this case, the disturbance power of 85 megawatt is simulated. And for disturbance power of 85 megawatt, this table shows the load shedding amounts, equivalent Shapley values, and load shedding locations. And when we simulate these values, from this table, we can see the load shedding amount for 3 locations, bus 5, bus 6, and bus 8. When we simulate this in RTDS, for example, if here the outage of 85 megawatt is simulated after 5 seconds, at 5 seconds, and then if there is no load shedding, then frequency decreases. Here we can see that frequency decreases to value around 58.7 hertz. But when load shedding is applied at 7 seconds, then the frequency returns back to the original value. Therefore, we can say that the proposed approach can effectively bring the frequency back to its original value. From this figure, we can see that when here frequency load shedding is applied after 2 seconds, that is at time 7 seconds. Outage started at 5 seconds, but it was changed was load shedding was applied at 7 time t equals 7. Conclusion: in this paper, a cooperative game theory based two-stage unofficial load shedding scheme has been proposed. In the first stage, the disturbance power was computed using initial RCOF. And in the second stage, the load shedding amounts and locations were determined using 2 types of characteristic functions. Through the dynamic simulations of wake 9-bus system using RTDS, it was shown that the proposed approach can effectively implemented for frequency control of power systems. Thank you.